Hi there! In this video, we're going to understand the formal definition of limit, also known as the epsilon delta definition, and an example of how to find delta given a certain epsilon. Let's begin. The definition starts with for every epsilon greater than 0. So this means that for what is going to be the value, the limit, the value L, we're going to consider an interval of size epsilon. And you can associate this with like a Tetris game or finding a missing piece for a puzzle. So you have a space here. So we're going to find a piece here. When you can project it, it's going to fit inside the missing piece. Okay, so for every epsilon greater than 0, we're going to find a delta such that all the values here, which are in the distance less than delta, when I find the image, if the function is called f of x, the distance between the limit is going to be less than epsilon. So in other words, for every piece here, we're going to find a piece here that when I project to the function is going to fix right in. So it's kind of finding a missing piece of a puzzle, or it's like a Tetris game where you can find a piece that is going to fit here. So that's kind of what the definition is trying to say. Now let's see an example where we can find a delta for a certain epsilon. When do we use the epsilon delta definition? When we need to prove a limit. So if we need to prove that the limit of x approaches 2 of 4t minus 5x equal to 4, then I'm going to suggest as a first step to use the sentence of the definition, which is that for every epsilon greater than 0, there is a delta greater than 0 such that if the distance between those values of x minus c is less than delta, then the images of x minus the limit is going to be less than epsilon. And I'm basing this on the formal way that we write the limit. Okay? So we have here x minus c. So x minus c in this example is going to mean x minus 2. Okay, so I'm just going to replace the 2 here. Delta, we're seeking delta. So f of x minus L. F of x minus L, which is going to be this expression that we have here, 14 minus 5x minus 4. Okay, so we have, and this is going to be 14 minus 5x minus 4. Okay, so it's like filling the blanks. Okay, so we're going to replace the corresponding values based on the template of how do we write the limit. Now, we need to prove this. So this is an if-then concept. So if hypothesis, then the conclusion. But in the hypothesis, we don't have too much information, so I can solve this and then find this, okay? So we're going to be cheating a little bit, and we're going to start from the conclusion. And what we're going to do is we're going to be simplifying this absolute value, so we can see how to compare the x minus 2, the absolute value of x minus 2, and that value for which it's going to be compared, then that value is going to be the delta, okay? So if I simplify here, I can see that I can subtract the 14 minus 4, which is going to be 10 minus 5x less than epsilon. And my goal here is to find an x minus 2. Okay, so I can factorize here. And I have a 5 as a common factor. And I'm going to have here a 2 minus x. I'm getting closer. And I have the absolute value of a product, which I know that is the product of the absolute value. Okay, so I know that the absolute value of 5 is 5, so I don't need to write the symbol of the absolute value. And I have 2 minus x, but I wish to have x minus 2. But that's okay, because I know that the absolute value is going to return to me a positive number. So the absolute value of 2 minus x is actually the same as the absolute value of x minus 2. Okay, so we're good with that. Now we need to solve, or just solve for the absolute value of x minus 2. So the remaining step here is just divide by 5. So I have the absolute value of x minus 2 is less than epsilon over 5. So absolute value of x minus 2 less than delta. Absolute value of x minus 2 less than epsilon over 5. There we go. We found the delta. Okay, so we're going to take delta as the epsilon over 5, and this one is going to work. Okay. So it's like give me the epsilon and I'm going to give you the delta. So if your epsilon is 0.01, okay, then your delta is going to be 0.01 divided by 5, and so on. Okay. So this is like a general formula. Now, if the exercise, the limit that you need to prove is given a specific epsilon, it's just the same process but with that value given. Okay, so for every epsilon greater than 0, then suppose that the epsilon is going to be 0.2. Okay, so for epsilon given 0.2, the same process, we're going to find a delta for that value of epsilon. So it's the same process, the same steps, just going to solve for that absolute value. And then your delta for this one is just going to be 0.2 divided by 5. And there we go.